In question 6-66, it reads, CPM engineers are considering developing a private space rocket. In a computer simulation, the rocket is approaching a star and is caught in its gravitational pull. When the rocket's engines are fired, the rocket will slow down, stop momentarily, and then pick up speed and move away from the star, avoiding its gravitational field. CPM engaged the rocket engines when it was 750,000 miles from the star. After 1 full minute, the rocket was 650,000 miles from the star. After 2 minutes, the ship was 530,000 miles from the star. Stop video. First part of this problem is name the 3 points given in the information above. If x equals the time since the engines were engaged and y equals the distance in thousands of miles from the star. So basically I underlined some key details, like the fact that it's when the engines are first engaged, the rocket ship is 750,000 miles from the star. So that can tell us that at 0 being minutes, engines are engaged, the rocket is 750,000 miles from the star. Now I'm just incorporating this into thousandths, so this is 750,000, but for just to make it easy, we are just going to label it as 750. Then it says after 1 full minute, the rocket is 635,000 miles from the star. So then point 2 is 1 being minutes, the rocket is engaged, and then 635,000 miles. And then the last point is after 2 minutes, the ship was 530,000 miles from the star. So after 2 minutes, the rocket is 530,000 miles from the star. So those are our 3 points. So now moving on to question A. It reads, based on the points in part A, I'm assuming he means the part prior, make a rough sketch of a graph that shows the distance reaching a minimum and then increasing again over time. What kind of function could follow this pattern? So if I were to make just like a simple sketch, I would say this is a parabola starting low and then decreasing and then regaining. So that's just a simple parabola. So yeah, moving on to question B, though this is where it gets a little complicated. Find the equation of a graph that fits the 3 points you found in part A. So this is a 3-part equation, so you basically have to write out in this basic format. I'll write it up here. Y equals ax squared plus bx plus c. So that's like the basic format of the equation. So now we just have to punch in the x and y's to get our equation. So if we look at the first one, it is 750 is our y value equals, punch in 0 for for x. So it'd be 0a plus 0b plus c. So this just is 750 equals c. So we got our first value out of the way. That's really nice. The second equation starts out as 635. Remember, that's in thousands. Equals 1 is x, so punch it in, equals a plus b plus c. Now finally for our third equation, it is 530, again 1,000, equals, you take the 2, put it in for x, now square it, so you would have 4a plus 2b plus c. So those are our 3 equations, and now we want to get rid of a variable, and really the only variable we can get rid of in this one equation is c, so that kind of limits us to only being able to get rid of c. So just for simplicity, I'm going to get rid of the first and second one first. So I'm going to supply a negative here, and that's going to get rid of this c here and this c here. So then when we put this in, it gives us a negative 635 and a positive 750. So we take our calculator, take 750 minus 635. That gives us 115. So this is part of now our sum equation. So 115 equals. That's this first part of the equation. Now we have a negative a value, and that's nothing is up here compared to a, so it's just negative a. And then a negative b, nothing cancels out on the top equation, so now that's also a negative b. So now we're going to compare the second equation to the third equation. So again, for simplicity's sake, I'm going to leave this negative, and now this is getting rid of this c, so these two cancel. So now it's a negative 635 and a positive 530. So we're going to take a negative 635, and then we are going to add 530 to get negative 105. Negative 105 equals, now this is a negative a compared to a positive 4a will give us a 3a value, and then negative b and 2b, this just gives us a singular b. Alright, so now we're going to sum these two equations by getting rid of another factor, and now the easiest one that we can see is b, because here's a negative, here's positive, so we have to do nothing to the equation. These just zero out. So now you put these two equations together, and this is a negative 105, and this is a positive 115, so this just equals 10. So 10 equals, and now here's negative a and 3a. These add together to get 2a. So then if you do simple algebra, we can see that 5 equals a. So we have two of our variables. We have that c equals 750 and a equals 5. So now we can basically pick out any equation we want. And again, for simplicity, being that this has singular values, I'm going to go with the second equation, and we just put in these values that we found for different variables into the equation. So 635 equals 5 plus b, our last unknown value, plus c. And c equals 750. So now we just do simple subtraction from each side. So we would take away 5 from this side to get rid of this 5 and leave b by itself. We would get 630 equals b plus 750. And now we just have to get rid of the 750 to get b completely by itself. So we take 630, subtract 750, and that gives us negative 120. So negative 120 equals b. So now we have all three of our variables, and now we just have to simply plug it into this original equation up here. So y equals our a value, so 5x squared, plus our b value, which in this case is negative, so subtract 120x, and now finally we have to add c, and c in this case is 750, so plus 750. So that covers part B. So our last question is, if the ship comes within 50,000 miles of the star, the shield will fail and the ship will burn up. Use your equation to determine whether the spaceship has failed to escape the gravity of the star. So knowing that the y equals the distance and thousands of miles from the star, we put in 50 for the y. And x stays the same. So we put in our value from before into the equation, that 50 equals 5x squared minus 120x plus 750. Now to get this x squared singular, we would divide by 5 throughout the entire equation, because what we do to one side, we do to the other. So 10 equals x squared minus 24x plus 150. Now what we do is we have to subtract 10 from each side to get it to 0, to find our 0th term. So 0 equals x squared minus 24 plus 140. Now, to factor this out, we would do our generic rectangle, and we would put x squared in for this square and 140 in for this square. And through a diamond, we would do 140x squared on the top and negative 24 for the bottom. Now, what times what equals 140x squared but adds up to negative 24? That would be negative 10 and negative 14. Put those two values into either one of these two remaining squares and factor out the equation so that it makes sense. So the two factored forms are 0 equals negative x plus 10 and negative x plus 14. Now if we were to take each of these values aside, we would have 0 equals negative x plus 10. Now if we move this x over to this side by adding by x, we would have x equals to 10, which is one of the solutions, and we would have Oh, on this side, 0 equals negative x plus 14. Again, moving this negative x to the left side by adding by x, we would have x equal to 14. And circle that. Now if we put that into the equation, we would have 5, 10 squared minus the value of 120 times 10, and then add 750. Due to this equation, 50 does equal 50, so that is correct. Now, doing it with 14 for x, 5 to the 14 squared minus the value of 120 times 14 plus 750 gives us 50. And again, 50 does equal 50, so that checks out. So, as long as they do not leave the engines running for 10 minutes or 14 minutes, the ship should be safe. And that concludes question 6-66.